All right, hey everybody, for CircuitPython Day, we're doing a presentation on powering up your CircuitPython project with Adafruit IO. I'm Brent. I did a live stream last year with my colleague Trevor. This year we have a new colleague, Lauren, who is with us today, and we're going to talk about how Adafruit IO and CircuitPython can work together so you can make really great projects. Um, who are we? I'm Brent. I work on CircuitPython. I work on Adafruit IO. I work on Whippersnapper. So like anything firmware related that connects to the internet, I kind of have my hands in. I've also done projects. I write the IoT newsletter for Adafruit. And yeah, and Lauren, do you want to introduce yourself?
Yeah, hey, I'm Loren. I'm a longtime web developer, and I'm having a blast bringing the richness of the web all to this tiny hardware we love so much. I'm definitely learning as we go about hardware, but I know the web stuff, and I'm having a blast working with people like Brent to make awesome stuff. So yeah, it's cool to make this stuff kind of easier, or make the high-powered stuff much more easier to get into. So having a blast.
Yeah, so like when you see projects on Adafruit IO or like for Whippersnapper or CircuitPython, like you see the website, that's a lot of Lauren. We also have other people on the team. And if you see firmware, it's a lot of me, but it's also other people on the team. It's kind of like a team split into two distinct, like the web and the firmware side of things. Today we're going to be talking about, this is a different presentation than last year. Last year we mostly talked about It's a Snap and some projects that people built. This year we're specifically going to be talking about how you can make your existing project better, or how you can use CircuitPython to extend capabilities of your project that you don't normally want. How to use Adafruit IO to extend your CircuitPython project to parts that you really don't want to program. Like CircuitPython's really great for getting up and running with your code, but Adafruit IO will help you take it even further. So we're going to discuss what Adafruit IO is, Adafruit IO for CircuitPython, Actions, which is a feature that we've had, but Lauren spent the last year completely redoing it, and it's really awesome. Can't wait to show it off for your CircuitPython projects, and then power-ups for your CircuitPython projects. So yeah, Lauren, do you want to start with what Adafruit IO is?
Sure. Yeah. So basically, yeah, we make all this awesome hardware and we make it cheap and easy to get into, but it turns out to do really interesting stuff, you actually need a collaborator on the web or the internet. So that's where IoT platforms come in. But we also notice that IoT platforms are commonly kind of, how do you say, enterprisey. They're for people
Hmm.
building like the next Ring camera, like they're going to deploy 10,000 devices and sell them to customers and whatnot. But you might be doing that, but we want to make sure people who are just starting for the first time with a piece of hardware can do the cool stuff as well. So we realized we weren't going to be able to rely on any other platforms, need to make our own. So that's where Adafruit IO comes in. So it's an IoT platform that's made to be really, really easy to get started and get moving with, so you don't spend too much time kind of making puzzles and hurdles for yourself and filling out forms of things that don't make any sense to you, et cetera. So yeah, the overview is you connect you build your project, and then you can connect it to Adafruit IO. You've already got an Adafruit account, probably because you bought hardware from us. That same account works on IO. And you can kind of head over to IO and get things set up, drop an API key into your CircuitPython project, and start sending data to feeds. From there, you use that data to, as you're showing here, create dashboards so you can chart it if it's numeric data, or you can, print it if it's textual data, et cetera. We have various things you might want to do with that data, and that's of course also where we're adding new functionality even now. Did I miss anything, Brent?
No, I don't think so, except for so like Adafruit IO works with any CircuitPython board, not just ones produced by Adafruit. We have CircuitPython libraries to get started too. So like you go to GitHub or download the CircuitPython bundle. We have an Adafruit IO API library, which works with both our MQTT and our HTTP APIs. So like you get two for one. So any device you have, including like a Raspberry Pi that can run Python, you can connect to Adafruit IO, which is really cool. So like either Python or CircuitPython, if the device has internet connectivity, or like you can add it through like Ethernet or like cellular, then you're able to interact with something like what we're showing you, like a nice dashboard or feeds to historically logged data. So This talk's going to be a little bit different than we've done previously. We're going to focus on two features of Adafruit IO that help you extend the capability of your CircuitPython project. We're going to talk about actions first because they're newer, larger, and really interesting, and power-ups. There's also tons of features, so we're not going to talk about dashboard, feeds, widgets, like anything that is like fundamental or core to Adafruit IO. We're only going to talk about things that even are brand new and extended even further. So we'll talk. Lauren, do you want to talk about actions because you've spent a while working on this year?
Yeah. So yeah, and just jump in, Brent, if I get sort of misspeak or anything, but
Sure.
or miss something. But yeah, actions are basically a way to sort of do some more programming on the website, so you don't have to do as much in code. And there's some things you actually would have a really hard time doing in code, and having a collaborator in the cloud or on a server, as it were, is sort of necessary in the first place. So we wanted to make that stuff easy. So actions are how we're exposing that. We've had actions for a while. They worked in a different way, but lately, like you said, we've rewritten it and relaunched it this year with a Blockly interface. So it's now block-based, and you can sort of click together blocks to code up your own actions. And I'll demo that here in a sec. But yeah, the idea is that anyone can kind of code now, and you don't have to do it in CircuitPython. You don't have to do it all in CircuitPython if you don't want to. And so basically it's the automation portion of the IoT platform that actions make easier.
Yeah.
Also a quick demo of the basics of that. But what do you want to say anything else, Brent, about it?
Except for like this doesn't replace your CircuitPython programming. This is going to extend what you're already doing. So like you're still going to have CircuitPython code, still going to be running on your device, but there are some things that just don't make sense to be doing entirely in your while loop. And it could shrink the size of your code, give you more space for images, pictures, media that sits on your device. It also makes the code less complicated to read. So it's kind of like things that you don't necessarily want to put in your code.
Yeah. So we'll switch over to my screen now, and I'll do a quick live demo of it. So we're looking at my Adafruit IO account. I'm just going to click over to actions here, and I'm going to do a new action. Let me just close this. Do a new action, and I'll just say this is a demo. I could add a description if I wanted to make it easier to identify later. So this is action. So there's triggers, and then the thing, this triggers are what make the action run, and then there's actions, and the action is actually what happens when it runs. I'm just going to show you. This is just the intro one. I'll do a few more demos a little later to show off triggers and whatnot. But I just want to show you how sort of math works. So actually, I need to put a little log block in here so that I can log things out. So if I were to log ABC and then save and run, and say go ahead, enable it, and save it and run it, then it runs, and you see ABC, and that log block goes ahead and says, hey, that's actually a string. So that was a string in memory. So programmers will recognize that that we're dealing with actual programming things behind the scenes. If I go to math, I can grab the number block and drop that in there. I'll say 1, 2, 3, and I'll save and run that. And it says, hey, the output was 1, 2, 3, and that was actually an integer. Very cool. So what else can we do? So let's do some math comparison. So 5 equals 10. So that's probably going to return false. Yes, that gives me the false Boolean. Just sort of demonstrating that this is, you're actually able to program kind of quickly here. And this code is not executing in the browser. This code is actually executing in our server on the back end. So it's actually very powerful. We can scale it out as much as we need, et cetera. And that's kind of the point here is like, you only want to do so much on these tiny pieces of hardware, right? So we can do heavier stuff. We can make API calls. We can kind of already get stuff like set up for you and whatnot. But it's basically, you can program in sort of the same way. And there's higher level functions. So here's the round function. So does 5 equal, I'll say round 5.4. So they should be equal, right? Because that should get rounded down to 5. Save and run, true. And then if I say, does it equal 5.5? Save and run, false, right? So it rounded 5.5 up. But I could switch from the round function to the floor function, and now it's going to round down again, right? Floor goes to the lowest adjacent integer as opposed to ceiling, which goes to the highest. So run that, and that says true. So you can kind of quickly have a little dev code and fix loop just by kind of playing with these things. And then there's also variables, so you can create variables and set them and use them later and reduce use code reuse and whatnot. But yeah, so that's a quick demo of just kind of that. It basically works as a little programming environment that you can use. So let's move on.
So we're going to show extending a project with an action, right? So this is a bird feeder project that Noe Ruiz and the Spark worked on, I think last year. It takes pictures of birds. That's what it does. It uses a PIR sensor. It takes a picture of a bird that came near the bird feeder, and it sends it to Adafruit IO. So there's an internet-connected device running CircuitPython sitting in that bird feeder. So this is something that you can extend. This is a project where you can receive email notifications when a new photo is uploaded to an Adafruit IO feed, and that can use actions. But what parts of this use CircuitPython, right? We're still running CircuitPython. So the PIR sensor is detecting a bird at the feeder. That is something you would want to use CircuitPython for. That's a time-sensitive operation, and you want that sitting in that while loop in CircuitPython that's executing very, very quickly. You want CircuitPython to capture the image. Again, that's a time-sensitive thing. You want the sensor to detect that a bird is there and really take a picture quickly. And then you also want it to encode data to base64 to shrink it a little bit, and then send it to Adafruit IO to store it. So like we won't go over feeds, but like this is a feed. Feeds have history. And each like image string is stored there, so you can see all the pictures you've taken of your birds. Where this brings in actions is this is an action where it detects a new value. So it looks at the image string that we sent to the feed, and it says, oh, there's a new value from your device. We then create a variable like Loren was talking about, where we create a new variable called bird picture, and then you set it to your feeds. And then we have this email action, which allows you to take the subject and say, oh, your bird feeder took a new photo. And then your body of the email is the new bird spotted at the feeder. Click the button to view the image, or like click the link. And then you click it and you go straight to the feed, which is public. So that's one example of taking a project that you already have and logically extending it from CircuitPython to Adafruit IO. You can do this in CircuitPython. This is one of those projects that like Loren and I were talking about earlier. It's like completely possible to do this within CircuitPython. You can have an API that sends an email whenever you take a new photo, and you would have to retrieve the link from somewhere publicly hosted, like some server somewhere, and you would also have to set that server up, and you would also have to set this email client up in CircuitPython, and your main loop in CircuitPython is going to get really, really large. Avoiding that is this little block, this little action that we created that has very minimal blocks and very quick to set up. So that's an extension of a project.
Yeah, I'll show real quick how to put together a trigger and notification action. If you want to switch back to my desktop, yeah. So we're looking at the action that I was just creating. Let me just delete all this. Oops, thought I could. I know my hotkeys. Drag all this stuff to the trash. And all right, so triggers. So I'll go to a trigger and I'll say, so I'll grab the when something gets some data. So I'll do a quick action that converts Celsius to Fahrenheit. So I'll say when my feed Celsius gets any data. So this is a trigger. So boom, now whenever that feed gets data sent to it, the actions will run. So it's just that simple. And there are other versions. So you may want to say not any data, but any data that is greater than 80 or something like that. And then it will only fire if it gets data and it goes ahead and compares that data and makes sure that it's above 80, et cetera. So that you can do more interesting things as needed. But all right, so this feed just got data. So now what I want to do, I'm actually going to set another feed. I'm going to go to the feeds. I'm going to say set feed, and I'm going to go to the Fahrenheit feed, and then I'm going to convert that Celsius to Fahrenheit. I actually don't know the math for this off the top of my head. Do you know it, Brent?
Not off the top of my head.
Yeah, right.
It's like, well, I don't know how you do it in CircuitPython because it's a fractional.
Yeah. Right. I mean, I can do that too. But yeah. So anyway, so I can do some math, right? So I'm going to set this feed to be whatever's in this feed. I'm going to set the Fahrenheit feed to be whatever's in the Celsius feed. Plus 32 times. You want to nest more math. Again, I forget what the exact math for it is, but I could drop this in here, and then so it's divided by or multiply. Anyway, this would.
Yeah, it's times 1.8 plus 32.
Times 1.8 plus 32. Yeah. Okay, cool. I can do that. All right. So Celsius times 1.8. And then that whole thing plus 32. Sweet. So like that. So that would do it. So now anytime. Yeah. So now anytime you send a Celsius send any number to the Celsius feed, it will perform the convert to Fahrenheit math, which we just threw together here quickly without even knowing it beforehand, and it'll write it to this other feed, the Fahrenheit feed, and that would be it. You'd be done. If you're capturing Celsius and you wanted to be capturing Fahrenheit instead, and you've got two feeds, you could do that with just this. I did say I was going to show a notification. The notifications are here, so you can send an email, you can send an SMS. SMS is IO Plus only. That costs us money to send, but we'll talk about the pricing on that here in a sec. But just FYI, when you see something that's kind of crazy heavy or something we obviously can't do for free, we do have a cost to it. And there's also a webhook where you could post some data of your choice to any URL. So that pretty much lets you do quite a bit of stuff already. We will be adding even more stuff over time and making these things easier to use. But it's very powerful even today. And yeah, you don't want to send emails from CircuitPython, et cetera. It's kind of that'd be a lot more of a lift on the device. So,
or posting to a Slack channel or Discord,
True. Yeah, the webhook can do pretty much all that stuff, and then and we'll eventually add even more things to make it even easier to do direct stuff without having to know the webhook APIs of various things. Cool. Back over to the show.
And then there's another project I did this a long time ago for a weather station. A lot of people build CircuitPython projects with internet just to send environmental data to the internet. So Adafruit IO is a good platform for that. This is a really maximal weather station. It has an anemometer, captures the UV index, the wind speed, the TVO, CD, CO2 pressure. It's a lot of data, and it sends it to Adafruit IO. But that data is only useful if you check the website. So to extend it, you can receive a daily report of the weather through SMS. So CircuitPython, what does it actually do? We're pulling and reading all the sensor data. We're using the display IO library, which people who use CircuitPython should be familiar with, to display the data on the TFT display and format it nicely and show when it's sending to IO and when it's not. And then we're using the Adafruit IO library for CircuitPython to send that data to Adafruit IO. And that abstracts all of the complexities with actually how does it send the data, where you just do a quick API call to send the data to the feed. So to do this project where we really want to receive a daily report of the weather, from CircuitPython, we can develop or find an API that allows us to send SMS data. You need in CircuitPython to wrap this API that you find online. And it also requires these billing constraints. So very few services online are going to let you send SMS because that's a pretty common vector for spam. So you'll also have to handle that and handle wrapping the SMS API for some website or service you found into CircuitPython. And then you need to use that API so you can send data every morning through SMS. So how does your CircuitPython module do that? You could get the time from an RTC, like a real-time clock that sits on a board. That's a physical clock. Or you can also pull it from the internet, so a web-based time source. And every single day you would have to pull that. You need to add the math for that. You have to account for leap days, leap years, any time variation as well. Or you can use actions. So there's the schedule block that Loren showed as well. So Loren, you want to explain the schedule block a little bit? Because my familiarity, if it is only clicking the everyday button.
Yeah. I'll show it off here in a sec. So right. So I had a trigger that was set up when a feed gets data. Instead of waiting for a feed to get data, you can set up a schedule and just automatically run something periodically, and you've got kind of some power for how to do that. And this one is, let's go ahead and jump over to the demo, and I'll just start kind of showing it. Yeah, so right, so it's also in triggers, so it's schedule, so it's this interesting schedule block. So yeah, so you could do, let's see, so I've got, this is at minute. You can click this and change to, so we could switch to every minute. And now that's like the maximal. It's like this is going to run every single minute. This is going to wake up and run all the time. You could switch it to where that's the case only in certain months. So in this case, how about it does it every minute in January? Or let's play with the days of the week. Every minute of every Monday, every weekday, every Monday through Friday in January. Or maybe only between the hours of, so I'll switch the hours to this thing. Every hour between the hours of 9 and 5, because we're all just working for the weekend or whatever. Oops, so 5's not going to work because this is military time, 17. So there's 9 to 5. So, all right, so every hour between 9 and 5, Monday through Friday in January, this will run. So, for those of you that are programmers or know sysadmin stuff, it's just a cron string in the background. But there's various ways you can specify things. Yeah, and then so the cool thing too is we have this weather block. Right. So what do you want to do? You want to send an SMS. So you see, we don't let you put the number in here. You basically set up one phone number for yourself in Adafruit accounts, and then we will only send to that address. As Brent mentioned, it's a huge spam vector. And again, we're not trying to make the next Ring doorbell where you're going to have thousands of people using this. This is for you to get something done quick. So yeah, so what I'll do is I'll use a variable. I'll say create new variable. I'll just say humidity. Okay, now that's on here. So I'll pull out the set variable block, and then I'll pull out the weather block. And I've already set up locations. I'll jump over to the power-ups tab real quick. So here's the power-ups you can use. I've already got weather set up. I've already set up a few things, various places. So those appear here. So because they've been set up over there, they appear here. Look at Grand Rapids, and then what community you can pull the current. You can pull what's going to happen in 5 or 30 minutes, and those are just precipitation options. You can check if rain's coming. You can look at the this hour or a future hour up to 24 hours away. You can also look at the entire day up to 10 days away, 9 days away. And whoops, excuse me. Right. So what is humidity in here and easy? I don't even know. Let's just assume that maximum temperature, fine. Right. So anyway, there's many metrics you can grab. And again, like you could figure out a weather API, set yourself up on it, get an API key, call it yourself, etc. Or you could click a few drop downs here in Adafruit IO and have it just work. So I'll send myself a message that says the humidity is now. I'm sorry that this is kind of an ugly template. I know that block doesn't work super well, but all the text is the humidity is now, and then I can reference a variable by saying open bracket, and I'll say vars dot humidity, and that will there. So now every hour in January on weekdays between 9 and 5, I will get a text that tells me the current humidity. Well, actually, this one will give me the current humidity in Grand Rapids 9 days from now, which is not super helpful. Probably want to do now, and yeah, then there's humidity now. Yeah, and that's a real value. That it actually just hit the API, so that's the real value here in Grand Rapids right now. It's 60%. Yeah, there you go. Did I miss anything you'd want me to cover, Brent? Well, I've got it open.
I don't think so. This is great. And then like you could see like if you open the metrics again, like when you have like this is pulling from Apple's weather kit, which was previously Dark Sky when they bought it. But like when you pull from a weather API in your CircuitPython project, like the response is massive. Especially if you're getting the entire forecast. Like the forecast includes so many variables. And like you can parse it through JSON. Like JSON's really easy to parse in Python, which is great. But it's like you are still receiving that entire request back into memory. So like this is a really fast way of doing weather-based projects with a CircuitPython device. Like instead of SMS, you want to display it on a feed, and you want to display that feed on an ink display. You absolutely can. You want to send it to your Fruit Jam and push it out to a TV. You can. So like this is a way of really extending and harnessing like the power of like Adafruit IO with your CircuitPython project.
Yeah, and this one didn't. This one actually, this demo I did doesn't include any CircuitPython, right? Like I'm not doing anything
No.
with feeds or anything. So in some cases will be like that. You just want to do a simple thing. You don't even need a device anymore. But more interesting, you could also send this stuff to a device. So you may have a device. Maybe you've got a mag tag on your fridge, and you want it to update with the live humidity. Well, you can have Adafruit IO do the work, hit the API for you, get all the weather stuff handled. Like you said, parse that JSON. Those JSON responses are huge. You don't really want to be parsing JSON in constrained environments. Just let us do it on the server where we have infinite memory, essentially, right? And then you could send it to a feed. So all you just you could set a different feed to basically that variable that I created. Boom. Now that feed will get set, and then you go rig up that feed, rig up your mag tag to display whatever's on that feed through polling or what have you, and it'll just get updated. So yeah, so it's a way of kind of just removing like the parts that get sticky and hard on device and handling them in a much easier environment and letting you just kind of get down to what you want to happen on the device. I'm really proud of it.
Me too. Let's go back to the presentation. All right, cool. And then Lauren briefly just showed this. So like there are power-ups. So there's the weather. This is a service that uses Apple Weather Kit. Messages, which we showed, which is SMS. We also have a time service that connects your device to a clock that actually synchronizes to your time zone, which is really nice. So these are just like things that we're providing to you through Adafruit IO for your CircuitPython project. So we also have AQI coming soon, probably sometime in the next 2 weeks. And instead of using, it's going to connect to like these APIs that exist, like WeatherKit, but it's going to make actually getting the data from them easier because you only need your Adafruit IO API key. You don't need your EPA now and your Adafruit IO API key to build a project. And we might do TTS as well.
For those that don't know,
oh, sorry, that's yeah, that's air quality. We've been talking about so much over the last few weeks. Yeah, so that's like your air quality metric.
I think some people are near wildfires and they are very up to date on it, and some people are not. So yeah, it's either really interesting to you or maybe you never thought about it.
Yeah, definitely a metric that we've been watching very carefully, and people are super into it if they're near natural disasters.
Cool.
And then
I just did that demo. Yeah.
Cool. And then okay, but is it free? So if you have an Adafruit account, you have an Adafruit IO account, and we have a really generous free tier. So we give you 30 data points per minute. So that's how many data points you can send to Adafruit IO from your device, your CircuitPython device. 30 days of data storage actions every 15 minutes, 5 dashboards that we showed initially, like those really nice charts, and then 2 whippersnapper device limits, which we're not going to get into, 5 groups, and then 10 feeds. If you want to pay us, which would be great, it's $10 per month. It's $99 per year. It supports what Lauren and I work on. It also supports Adafruit as a company. You unlock all your limitations. So you have unlimited dashboards, you have unlimited groups, unlimited feeds, you get SMS, you get weather, you get double the rate limits, which is really nice, and double the storage. If this is not enough for you, you can also buy boosts, and then you can increase by 10 data points per minute for $2 up to whatever multiple you desire. Same thing for data storage. You're running a long-term experiment. You don't want a month of storage. You want half a year of storage to look at your river sensor. So that's how you would basically pay for Adafruit IO if you want, or just use it. You can use actions for free. They run every 15 minutes. So yeah, thanks for joining us. For more information, visit io.adafruit.com. And yeah, happy CircuitPython Day.
Yeah, it's great. Please come use it. Jump in, ask us questions. We love having you.